Now, the next thing I want you to know is how we take a test, okay? There are 5 steps to taking a test. How many steps? Type it in the chat. How many steps to taking a test? All right, 5. Angela says 5. Good. Okay, so step number 1 is to read the actual question. And the reason that's so important is because sometimes they make this scenario so long, but you don't need anything in the scenario. As we go through questions tonight, I'm going to show you like what's important, what's not important. Some things in questions, like it's just extra information that it's just there to confuse you or distract you. We could answer the question without that at all. So we're going to figure out first, what is the question? Then we're going to figure out, is this a 1-step question or is this a 2-step question? Now, what's the difference? A 1-step question is where you make 1 step from reading the question to the answer. You only make 1 step. So in a 1-step question, an example of that is like, what's the class of drug of albuterol? What's the class for oxygen? What's the mechanism of nitro? No matter what story they give me, it's not going to change that answer. That answer is always going to be the same. The mechanism of action for nitro is we take nitro, gets converted to nitric oxide, enhances cyclic GMP, or activates guanylate cyclase and enhances cyclic GMP, causes veno and vasodilation. They could give me 100 different stories, but that answer is always going to be the same. That's a 1-step question where I don't need a story. A 2-step question is where I do need a story, so I got to actually read the story. So that's going to be step number 3, is to read the story, but we don't read it like a book, and we also don't read it like an auctioneer. Oh, we got a 54-year-old. We don't read like that because we're going to miss all the clues. So we're just going to carefully analyze a few words at a time, picking out those clues. Step number 4 is sometimes we got so lost in the story, we forgot what the question was. So we're going to just read the question again. Okay. And then finally, we're going to let our brain come up with the answer. All right. And then whatever our brain said is the answer, we're going to trust that that is the answer. Now, let's put all this into practice. So we're going to go back to, who did I have? I had Teresa. Teresa, you ready?
Yes,
all right,
sir.
Let's go. So we're going to apply this. And hang on, let me just change out my view again for everybody. And let's see. Okay. Here, let's see. Can you see that okay?
I can.
Okay. So here's what we're going to do. We're going to start with where would you start when you're reading this? Where do you start?
At the question.
All right. So where's the actual question in all this?
Using the adult rule of 9s, what is the estimated percentage of partial thickness burn
Check you out.
surface
That's the
area?
actual question. So this question, no matter what they tell us in this story, the actual question is, what is the estimated percentage? So we need a number. Okay. Now, is this going to be a 1-step or 2? Can I just answer the question just based on that alone?
No, I think it's going to be a 2-step.
Yeah, this is a 2-step because I got to figure out how badly is this person burned. Okay.
Burn,
But
yes.
I don't need everything in this story. I only need enough information to tell me the burn percentage. That's it. So let's go through this one. And I want you to read out loud so everybody can hear you.
Okay, what did I do with my glasses? Okay, I think I can see. A 32-year-old male.
All right. And I'm going to highlight like what's actually really important for you to know. Keep going.
32-year-old male was pulled from a house fire. He is awake, coughing, and has partial thickness burns to his entire anterior chest, entire anterior abdomen, and the entire front of his right arm. He also has
Stop right there.
superficial.
Stop right there.
Okay.
Now watch this. I don't need anything else in this question because this actual question just wants me to calculate a percentage. These vitals don't matter because those vitals are not going to change the answer to this question at all, right? All I needed was enough information to pull out enough clues to figure out this percentage. So in this case, we're going to use our rule of 9s. Is this an adult or a kid?
Adult.
All right, this is a 32-year-old, so it's an adult. Why do I need to know that? Because the rule of 9s is different when you're talking about adult versus pediatric patients. So let's go over the adult rule of 9s. All right, so here's your patient. All right, we got a head. We got here. Let's clean this up a little because Teresa's already making faces about my drawing. I know it. All right, so here's this patient, right? And it doesn't have to look good, but let's figure this out. Okay, so here's your patient. This patient has partial thickness burns. Why did I highlight that? Because when we're calculating the rule of nines, what matters is partial thickness and full thickness burns, not so much superficial. So you may have learned it as first, second, third, or first, second, third, fourth degree, but we kind of ignore superficial burns when it comes to like fluid resuscitation. So we're specifically looking for burns that are partial thickness and full thickness, okay? So he has partial thickness burns to his entire anterior chest. Now the chest is just, so when, all right, so this whole thing here, that's the thorax, but we have a chest and we have an abdomen, okay? Now this whole thing is 18%, but the entire chest, that's 9%, okay? The entire abdomen, the anterior portion of the abdomen is what percentage?
9.
That's also 9%. So this whole thing is going to be 18%. Now he has also partial thickness burns to the entire front of his right arm. So the anterior part of his right arm. So over here on his right arm, we're going to say this is the front part. How much is the entire arm for an adult or kid?
9. It's
The
9.
entire arm, front to back, is 9%. But if they're only saying burns to the front, that's half of it. So what's that going to be?
That's going to be
4.5.
4.
Yeah, so we got 4.5%. Okay. So now when we add all this up together, what's our percentage? What's our total percent burn surface area? So we've
22.
okay. So in this case, we got 22 and a half. So yeah, in that case, in fact, this was like an EMT level question that could be found on an exam for EMT, AEMT, or a paramedic. Okay. This is just a basic question where it's just you knowing some kind of basic information. Okay. So good. How about you do about 5 in a row? You ready?
Okay.
Okay. So since you're ready, since you're so good with calculating burn percentages, let's go to question number 2. All right. So this is more of a paramedic level question or an advanced CMT question. So let's keep going. Now, this is a separate question. So start with a question, Teresa.
Let's see.
Starts right here.
Using the Parkland formula, how many lactated ringers should be infused per hour over the next 6 hours?
Okay. So the question needs to be so much per hour over the next 6 hours. That's what we're trying to figure out. This is going to be a 2-step question. We need a story here. And they want us to use the Parkland formula versus the consensus or the Brook formula. Okay, we're going to go with Parkland. First of all, what is the Parkland formula?
Yeah, I don't know.
All right, so we're going to get to that. Hold that thought. So let's just go to the question then.
Okay.
All right, so let's start with the question. For the rest of you, type it in the chat. Tell me the Parkland formula real quick. But Teresa, you keep going with the questions. Let's start here.
Okay. A 154-pound adult has partial thickness and full thickness burns to his entire anterior torso and the entire left arm.
Okay, hold on.
The
So
burn-
entire anterior torso and entire left arm. Okay.
The burn occurred 2 hours ago.
Okay, that's probably important. Okay, keep going.
Using the formula, how much lactated ringers should be infused per hour over the next 6 hours?
All right, so Maris says that it's 4. Okay, that is right. So this is the Parkland formula for everybody. So Parkland, okay? Now, why do we care? It's because burn patients, what are the 2 biggest killers of burn patients? What are the 2 killers of burn patients?
Fluid loss.
Okay, so we're going to call that dehydration, and that dehydration that gets worse can lead to what kind of shock? What category of shock would it be for fluid loss? I got it, Amanda. No problem. Okay, so that's going to be hypovolemic. So hypo is not enough. Volemic is volume. So when you lose in volume, that's hypovolemic shock. So number 1 is going to be dehydration that can cause hypovolemic shock. Number 2 is going to be infection. Okay. See, that infection, what can that lead to? The infection can ultimately result in septic shock. So notice
Mhm.
how both killers ultimately result in some type of shock. Now, all types of shock, is it primarily an oxygenation, a ventilation, or a perfusion problem if it's shock? What kind of problem is
Perfusion.
this?
Perfusion.
Perfusion. Okay, shock is the definition, or the definition of shock is inadequate or hypoperfusion. So, of course, it's a perfusion problem. That's why we have to be so aggressive with our fluid resuscitation in all burn patients. Same for septic patients. Okay, now the Parkland formula says that we take the number 4. This is just a calculated value, it's
Mhm.
always going to be 4. We take just the number 4, we multiply that times the patient's weight in kilograms. Okay, patient's weight in kilograms, and we times that by the percent burn surface area. Okay, so it's 4 times weight in kilograms times the burn percentage. Now, in this case, did they give us our weight in kilograms?
No, they gave it to us in pounds.
All right, so what's our conversion from pounds to kilograms? All right, so to go from pounds to kilograms, we take the weight in pounds divided by 2.2. So if we take, so for everybody, just do that for me on your calculator. Go 154 divided by 2.2. And what are you going to get? You're going to get 70 kilograms, okay? So 70 kilograms. Now, so we got the 4 part because that's just a
Mhm.
constant, and we got the weight because they gave us the weight. We just had to convert it from pounds to kilograms. Now, the only thing left to figure out is the burn percentage. So let's figure this out. So, what is this patient's burn percentage? This is an adult or a kid?
Adult.
This is an adult. Okay, so let's figure out this patient's burn. Okay, so where's his burn? He has an entire anterior torso. So torso, that's going to be consisting of the
The
chest
whole
and the abdomen. So that whole thing is how much? That's
18%.
going to be 18%, and the entire left arm, not just the anterior, not just the posterior, but the whole thing. So what's the whole left arm going to be?
Another
That's going to be
9%.
9. So when we add those two together, what's our percent burn surface area? 18 and 9, that's going to be
27.
27. So here's what I want everybody to do. Take 4 times 70 times 27, and what do you get?
70 times 27. 7,560.
Okay, so you gave me, so whatever number you get, that is
Mhm.
the amount of fluids they get in the entire 24 hours. Now,
They wanna know
when
what's
does the
over the
clock
next
start? It's from the time of the burn, not when you show up.
hours.
Okay. So in this
Mhm.
case, this patient has already been burning for 2 hours.
2 hours.
Okay.
Mhm.
So immediately we need to be stopping the burning process. Okay. Some of you have the answer already, but what we're going to do is whatever answer you get. So 4 times 70 times 27, I think you said 7560. Is that what you said?
Yes.
Okay, that is the amount. So this entire 7560 is the amount over 24 hours.
Mhm.
Okay, but what we have to do is we have to take that number and we have to cut it in half. So if I take 7560 and I cut it in half, we're going to give half of it in the first 8 hours, the other half over the next 16 hours. So what's half of 7560?
3780.
Okay. So that means he gets 3780 for the first 8 hours and then another 3780 for the next 16 hours. In this case, this burn happened when?
2 hours
Two
ago.
hours ago. So so how many hours do we have left of the 8? If 2 hours have already been used up and we didn't give fluids, we got to make up for the lost time, so to speak. We got to make up for the lost fluids. Because
Mhm.
in the 8 hours from the time of the burn, he has to get that amount of fluids, except we've already lost 2 hours. So what that means is now this 3780, instead of it
Mhm.
being given over 8 hours, it now has to be given over 6 hours. So we're going to take this 3780 and divide by 6. And what do we get?
Mm. 6:30.
Okay.
B.
And just like that, that's our answer. Now, obviously, it took me a little longer to explain it than it's going to take you on a test, but that's how you would approach like one of those burn kind of questions. By the way, what is our preferred fluid in a burn situation?
Lactated
All right.
ringers.
And in fact, that's what they wanted us to give. Now, why is
Mhm.
Ringer's the preferred fluid in major trauma, burns, and sepsis compared to normal saline? Why is Ringer's the preferred solution here?
It prevents
All right, so let me help you
this.
out. So in normal saline, it's made up of sodium and chloride. What happens
Mhm.
is this chloride leads to acidosis. And for those of you who were with me last week, I went through a whole thing about the acidosis. But the acidosis is also going to lead to vasodilation, and vasodilation is going to lead to shock. Remember, the two biggest killers in burns are dehydration, which can lead to hypovolemic shock, and infection, which can lead to septic shock. So you don't want to, they already have two things that can give them shock. You don't want to give them fluids that's also going to worsen the shock. Does that make sense? So
Mhm.
Ringer's, because it doesn't have chloride, instead Ringer's has sodium, potassium, calcium, and lactate instead of chloride. Because it doesn't have the chloride, it's less likely to cause acidosis, less likely to worsen the shock. Does that make sense? All right, you're
Makes
on a
sense.
roll, Teresa. Let's bring it. Let's all right. Don't embarrass us now. Let's keep it moving. Okay, you're doing good. You're doing well. All right, let's take this next one. Let's take question number 3.